Let's talk now about static versus dynamic pressure in fluid flow. At first, what is static pressure? We've already addressed that, but the definition of the static pressure is the force per unit area acting against a surface, as a reminder. So for a box laying on the ground, the pressure of that box against the floor is F divided by A, where F is the weight of the box, of course cancelling or neglecting the atmospheric weight, and A is the area of contact between the box and the floor. That's where the area where the box touches the floor. As for fluids, the pressure is reduced to rho gh, as we mentioned before. So pressure is equal to force divided by area. Dynamic pressure of a fluid. Dynamic pressure of a fluid is the pressure in motion associated with its kinetic energy. Kinetic energy of the fluid in motion. Unlike the static pressure acting against a surface and pushing over it, dynamic pressure is the pressure of a fluid in motion. So let's say a flat surface was suddenly placed in the flow path. The static pressure that will be exerted with the flow will be equivalent to the former dynamic pressure. That's like a kind of approximation into what dynamic pressure is. Q is equal to 1/2 rho v square. So v here is the velocity actually of the moving fluid. So it is close to the formula of kinetic energy, by the way. So Q equal 1/2 rho v square, where rho is the density of the fluid. By the way, if you've ever heard when they launch a space shuttle or something, in midpoint during the rotation of the shuttle or the rocket as it crosses through the atmosphere, as it cuts through in order to escape gravity, at some point they say we are max Q. Max Q means maximum dynamic pressure. This is what they are referring to. So an example, what is the dynamic pressure Q of gasoline flowing through a pipe traveling 3 meters per second? At first, the density of gasoline is around 775 kilograms per meter cube. By the way, it changes. It changes because of temperature. So it's not a steady density, okay? But we are considering the most optimal conditions where you have a cold weather. So the density would be very low. All right, so Q is equal 1/2 rho v square. Q is equal 1/2 775, okay, which is the gasoline density, times the velocity square, 3 square, equal to 3487.5 Pascal or Newton per meter square.